Hello everyone, in this video I want to talk about these awesome single board computers. First, I want to talk about the definition. What is a single board computer? Well, you can see right here I've got these two things. Now they are definitely single boards and they are definitely computers, but they're not single board computers by this definition. A single board computer is a computer that's on a single board that has a microprocessor. These here do not have microprocessors. They have microcontrollers. And I'll make another video to talk more about the differences between a microprocessor and a microcontroller. But here's another single board microcontroller board. But that's not what we're talking about today. What we're talking about today are these awesome single board computers. There are so many brands of single board computer, and the one you're probably really familiar with is Raspberry Pi. Well, these are not Raspberry Pis. These are Orange Pis. The Pi thing seems to be really popular for single board computer makers. I guess they're all trying to copy Raspberry Pi. This is Orange Pi, like I said, and there is another notable brand called Banana Pi. But today we're talking about these Orange Pi boards. I really love these boards. They are awesome. These range from several years old to brand new. So I want to go through, I've got a list to kind of help me, and I want to go through and talk about these kind of from oldest to newest or worst to best. I don't know. It's not really categorized very strictly. So first up, we have this one. This is the Orange Pi 3 LTS. It has 2 gigabytes of RAM and an all-winner H6 CPU. It's a quad-core CPU that has 4 Cortex A53 CPUs clocked at 1.8 gigahertz. It has a Mali T720 GPU, and like I said, it has 2 gigs of RAM. It's low-powered DDR3. It has an SD card slot, and it also has 8 gigabytes of onboard eMMC memory. The eMMC is preferred because it's more reliable. It can survive more write operations. Also, it's generally faster. I say generally because this is kind of an old eMMC chip, and there's a lot of really new SD cards these days that are really fast. And we can see the ports. It's got HDMI, 3.5 millimeter audio jack, 2 USB 3.0 ports, Ethernet, gigabit Ethernet to be specific, and a USB 2.0 port. This one also has an infrared receiver and, of course, a GPIO cluster. And then here we have USB, I think 3. I don't know the version. This is a USB-C port, and you can use it for power. You can also set it up for USB on the go, so you can actually plug things into it. Okay, let's go to the next one. That's these right here. I just got this one in the mail, and I've had this one for, I don't know, maybe a year? I'm not sure. So this is the 2 gigabyte version of the Orange Pi 20W. It's hard to keep up with all these model names. This one has an all-winner H618 quad-core Cortex A53. It's at 1.5 gigahertz. It's got a Mali G31 MP2 graphics processor, and the RAM is low-powered DDR4. It's newer than the other one. It also has 16 megabytes of SPI flash that you could, put a bootloader in or something like that. And there is no eMMC storage here. It's just the SD card. And it has the, the pretty standard 40-pin header. You see I've soldered to that there. And here's the Wi-Fi chip. Here's the other side of the board. Let's focus the camera. There we go. Nope, it is still out of focus. I guess that's as good as we're going to get. Oh, it's because I was zoomed in. It just looks a little blurry. But there it is. We have a mini HDMI, which in my opinion is a lot better than the micro HDMI. And then 2 USB-C ports. And then we have this, it's either for display or for camera. I'm not sure. Let me see. It doesn't say. So I'm not 100% sure. Okay, I was totally wrong about that. I just looked it up. It's neither a display or camera port. It's for a proprietary expansion board, you know, so you can put another board in the casing that you use for this and connect it with this cable, and it gives you 2 USB ports, USB 2.0, 100 megabit Ethernet, an IR receiver, 3.5 millimeter audio jack, and a composite video port. It also gives you some power buttons and a reset button. So that's pretty cool. And this, I mean, it's the same exact one, right? But it's just got 4 gigs of RAM. And I haven't soldered anything to it yet. It's surprisingly capable. I mean, you can run a Linux desktop on this. I mean, I'm not going to say that it feels like a desktop PC. It doesn't. I mean, it's a little sluggish, but it's just surprisingly powerful for its cost and size. Okay, let's go to the next one here. This one is the Orange Pi 3B. It's the 2 gigabyte version. It has a Rockchip RK3566 quad-core Cortex A55 CPU. It's clocked at 1.8 gigahertz. It has a Mali G52 2EE GPU. It also has a dedicated AI processor, but it's really nothing impressive. It only does 0.8 tops when you're doing int 8 mode. I mean, it's still pretty impressive that something this low cost, this low power, and this small has a dedicated neural processing unit, but it's pretty weak. This RAM is low power DDR4X, and it actually is surprisingly good. It has 16 megabytes of SPI flash, and it also has, check this out, it's got an eMMC socket, so you can, you know, put an upgradable chip there. I've seen them as high as 256 gigabytes for like $60 or something like that. And look at this, it has a full-size PCI Express NVMe socket. So you can put like a 1 terabyte super fast super fast NVMe drive in there, and, you know, really go to town with this thing. It has gigabit Ethernet and Wi-Fi 5. It's a newer Wi-Fi. Well, the world has moved on. You know, we have like Wi-Fi 6 or probably 7 by now, but it's a relatively modern Wi-Fi chipset. So let's take a look at the ports. It's got the USB-C here, HDMI, full size, 3.5 millimeter socket. And then I've already explained this. 1 USB 3 port. Some people complain about that. I really don't. I just don't care. And 3 USB 2.0 ports. And then, of course, we have the 40-pin header. And this has, you can see why I thought this was either a camera or a display, right? Because this has MIPI ports for a camera and for a display. Super, super nice. I really, really like this board. There's a header. I believe this is for a real-time clock. No, this is it right here, RTC. Real-time clock. So you can put a little battery there, and that way if this loses power, it does not lose precise timing. And then this right here is for a fan. Really nice board. It's amazing that computers have gotten to this state. Okay, let's go to the next one. Okay, these last two are my favorites. And this one is particularly, I don't know, I don't know if it's my favorite, but it's just the most interesting one in my opinion. So we'll do that one last. This is the Orange Pi Pro 4, or sorry, Orange Pi 4 Pro. They have a lot of different models. This one here is really, really nice. It's really fast. It has an Allwinner A733 CPU. It's 8 cores. It's the big little architecture. It has 2 Cortex A76 CPUs that are clocked at 2 gigahertz, and it has 6 Cortex A55 CPUs that are clocked at 1.8 gigahertz. It has an Imagination BXM 464 GPU, and it has a 3 tops, so 3 trillion operations per second dedicated neural processing unit. Again, not super fast. Just for some comparison, a several years old NVIDIA V100 graphics processor does, I believe, like 125 tops with floating points, you know. And this is doing much more simple kind of numbers, integers, and it can only do 3. But still, it uses hardly any power. They're light, They're small, they're low price, so the fact that you can do 3 trillion AI operations per second on something like this is quite amazing. For an SBC, this has a lot of RAM. This has 8 gigabytes of low-power DDR5, which is pretty cool. It also has, of course, the SD card slot, and it has an eMMC socket. You can see with my case frame there that you can't use that, but that's okay. I'm building this for a certain specific application, and I'll talk more about that in a moment. It also has the full-size laptop style PCI Express NVMe socket, which is really, really awesome. And I believe, yeah, this is another camera connector here. Let's turn it back over. Just look at this. I mean, this is a very cool board. It has the MIPI camera and display connector as well. And let's go around the ports. Pretty standard fare. We've got the USB-C socket. Oh, there's a microphone right there too. We have the USB-C port, we have an HDMI port, 3.5 millimeter audio jack, gigabit Ethernet, and again, 1 USB 3.0 port and 3 USB 2.0 ports. And then, of course, the Raspberry Pi compatible 40-pin GPIO header. Look at this. Just look at this. It's so nice. It is really nice. This thing can do 4K video at 60 frames a second in hardware. But look, there is like no support for this yet. I've tried several different operating systems. I just can't get GPU acceleration to work. You know, I am a program developer, but making proprietary graphics blobs for GPUs is a totally different ballgame. It's a shot in the dark with everything. You just don't know how the chip works. It's not a matter of being a good programmer or not. You just don't have access to the information. So unfortunately, there's just nothing I can do about that for now. But it's just a matter of time before they release those blobs. And yes, they're literally called blobs. I really love this board. This is the first board that I'm loading my battery design system on. So basically, instead of paying a monthly fee, you'll be able to just buy this board, hook it up to your network, and then instead of going to my website to use the battery designer, you can just go to the IP address of this board, and it actually works really great. It generates models about twice as fast as it does on the server. And I'm going to start selling these. That's basically why I've got all these. I'm going to build different things, load different softwares on them, and sell my software as a physical device. I've actually already sold this one, which is why I am doing this. Because the application it's being used in, you know, it can just use the SD card. It's totally fine. It doesn't need this eMMC socket. It doesn't need this. So I'm designing this frame to put it in a case with that in mind. Now check it out. It just looks like it's just random on the board, but if you really pay attention, you'll see that the frame I designed, you know, it totally dodges all of the components on the board. Any place you see that orange frame laying on the board, it really is laying on the board. It's not touching any component, even though it does come really close in some cases. Pretty cool, huh? And here's the SD card slot. It's not exactly perfect, is it? You can see there's a little gap there. That bothers me. I'm going to fix that. I want the gap to be equal on both sides. I know it doesn't matter, but it matters. Just want to give you a good money shot of this board. Just look at it. It is so nice. Now, my favorite. I really love this thing. Look at it. Just look at it. This is the Orange Pi R2S. It's an 8-core RISC processor. It is the KYX1 CPU, to be specific. It has 8 CPU cores running the RISC-V architecture, and they are 1.6 gigahertz apiece. They're not the fastest CPU cores. This is not the fastest SBC, but it is just so interesting. These two ports are 2.5G, so that's 2.5 gigabits a second. These are gigabit. So you could make like a router with this, or a nice pocket switch. You could make a device that blocks ads at a network level. Here's the USB-C port. Of course, just talked about these. And then we have one USB 3 port and one USB 2 port. You notice there is no video for this. There's also no SD card slot. This has 8 gigabytes of eMMC built in, and there is nothing you can do about it. There's no upgrading it. There's no SD card slot. So if you buy this, you have to have a very specific application for it, and you have to, know that you just can't do anything about storage. But you can always plug in, a really fast flash drive. And you can even boot from a flash drive, so you have actually a lot of options there. Now you notice all of these boards have this header. Look, you see this right here? And then on this one, it is right there. And then this one, it is right here. And then right there. And this one, well, it doesn't have any pins installed, but I'm sure it's there somewhere. You know what? Maybe not. Or maybe it just relies on the, they're in here somewhere. Anyways, what that is, that's the UART debug terminal. If you plug in a USB, TTL adapter or whatever to that, and plug it into your computer and turn it on, you will see Linux booting. Like, it is really cool. You can interact with the entire system regardless of like the network status, or if you have a monitor, or anything like that. So it's obviously optional on all these boards, but here, like I said, you really have to have it. That's the only way to set this thing up. And actually setting this up is quite a handful. What I ended up having to do was program it through this port. Yes, this port, which is really interesting. Check it out. I happen to have this. If I didn't, I would kind of be screwed. I don't even know why I have this or where I got it. But look at this. It is an A to A cable. Like, it looks like there was a mistake at the factory or something, right? Well, what you do is you hold this button right here, and then you plug in power, and then because you're holding that button, it knows to go into something called fast boot mode. Once this thing's in fast boot mode, you can use a proprietary piece of software that's provided by Orange Pi. It's not made by them, but they distribute it, and you can flash the board. And that's what I did. Well, that's pretty much it for this video. I just wanted to share all my boards with you guys. I actually have 3 more on the way. 2 of those are Orange Pi boards. I really love this product line, but I've got a Radza, I don't know how to pronounce it, RADXA board on the way. It's pretty much exactly like this one. Really, other than the color, it's green. Other than the color, it's nearly identical to this one. It's got the same CPU, the same RAM, the same amount of RAM. Actually, no, it's the 4 gig version that I've got on the way. But it is much better software. It has much better software support. So like, I'll be able to do, real 3D acceleration right away without waiting when that board comes in. Thanks for watching.